If you've ever wanted to learn about rendering on the web as well as different rendering modes we have such as client-side rendering, server-side rendering, and the whole other types of rendering modes we have as well as their pros and cons, when to use them and so on. Well, this video is for you because we're going to be looking at web rendering patterns. This is a video I've been wanting to make for a long time, but for some reason I've also been putting it off. We have a lot to talk about, but I will try to keep it as short and concise as possible while also making sure to give you all the necessary information you need. So without any further ado, let's dive right in. So what exactly is a rendering pattern? It's essentially a way to guide the process of rendering a web application. So the process of turning your data and your code into the view, which is HTML, in which the users see or interact with. Now, this particular process is called rendering. Now, one thing I would like to note is rendering can happen either on the client or on the server or both. So, for example, when visiting a web page using a client like your web browsers, maybe Chrome, Firefox, or other that you're using to watch this particular video, the core process of rendering the web page can happen or depend mainly on the client on your browser or from the server. And another thing to note is that it can happen all at once or partially or conditionally. And the mixture of all of these conditions is basically what gave rise to all of the rendering patterns that we have. Now, usually when you hear someone talking about websites or web apps, they mention that there are two types, which are static websites and dynamic websites. But yeah, it's a bit more complicated than that. Now, let's quickly look at the main rendering patterns we have for the web. Well, first, let's start with static websites. Now, these sites basically use static HTML page, maybe with CSS and JS. If you've ever started with learning maybe web development, this is the point where you start from. Your pages are then taken and uploaded to a server. When you visit a website, the homepage or index.html is typically sent to you. And for every other page you want to go to, you send another request to the server and there's a page reload. So this is best for something like simple websites, business websites, portfolio. As you can see, you make a page request to the server and the server sends back the HTML, CSS, and JavaScript. And for this, there really isn't much workload done on either the client, the server, or the build time when it comes to the rendering. Let's look at the pros and cons. Well, they are very easy to build. When it comes to static websites, they are relatively fast as the HTML files that are sent to the web browser do not require much server-side processing or any server-side processing in most cases, and they are great for SEO as search engines can crawl them easily. Now, when it comes to the cons, well, they are hard to maintain and to update, and they usually contain a lot of duplicate codes. This is very obvious if you've ever worked with any HTML file before. You just have to do a lot of copy and paste for your header, footer, and a whole lot of parts. And the page requests for each pages tend to make it slow, especially if you have a slow, bad internet connection, and also dependent on some factors. And it doesn't generally contain dynamic data. Now, the languages used when it comes to static websites usually include HTML for the markup, CSS for styling, and JavaScript for any functionality. Though there are some frameworks you can use to help you build out static websites, such as Yugo, 11t, and Jekyll. Some of the notable static websites we have is info.sem.ch, which is a really old website. We have itcorp.com, which I just found randomly on the web. Initially, this was fine. The internet and website was just basically for sharing of file and static HTML websites. But people needed more functionality and more dynamic elements, and that is where we have multi-page applications. Now, multi-page applications works in such a way that the HTML and the data, they are dynamically put together and passed by the server. So 100% rendered on the server, and the server sends back pure HTML content. Now, the appearance can change when the underlying data changes. So for this, we can say that majority of the work that is being done is on the server. They basically work similarly to static websites in the sense that when you want to go to another page and you click a link, the browser reloads while the server is working to put things together and send the HTML back to you. Now, let's look at the pros and cons. Well, it is great for SEO given the fact that you are getting a full HTML page and markup back, can have a fast initial loading because they only load the contents needed for each page. They are easier to build and maintain, especially when it comes to smaller projects. So the issue of okay, having to have a lot of duplicate code and so on are solved when you are writing multi-page applications. And they have great compatibility with older devices and browsers that may struggle with modern JavaScript. You can even build a whole multi-page app with little or no client-side JavaScript. Now, when it comes to the cons, it has poor navigation, as when you're moving from one page to another, well, there is a full page reload, and there's tendency to be a slower subsequent loads. They may require more server resources to handle page requests and rendering. And since the server handles the rendering, well, there's limited customization and interactivity on the client side. Now, some of the languages used are JavaScript, PHP, Python, and so on. There are tons of languages that have server capabilities. Almost all languages that I know of can basically do that. I mean, Go, even that, even Kotlin. I mean, does this mean basically all languages we have can actually be used on the server side? I think mostly. So far, so good based on the ones I've seen. The main ones I've seen and I've worked with, they can also be used on the server side. But what do you guys think concerning that? You can put a comment down below and let me know your thoughts. Also, there are frameworks when it comes to multi-page apps like Express for JavaScript, Laravel for PHP, Django for Python. And some notable websites are Amazon, Wikipedia. When you go to Amazon, for example, you'll see that whenever you click on any page or a product, it's actually make a full page reload. So yeah, that's a telltale sign of multi-page application. Now, static websites and MPAs were the two rendering patterns we had until when it came to the 2010s. After the iPhone came out and some of the smartphone came out, and people saw how fast and seamless the apps were. This is one of the things that actually inspired and led to the invention of other rendering methods. And the first one we're going to be looking at is client-side rendering. Now, here is how client-side rendering or CSR works. A single HTML is sent to the browser from the server with various JavaScript bundles. Now, the HTML and the data are dynamically put together and passed by the clients where hydration happens. And not the word hydration, we're going to talk about that in just a minute. Now, each route is hijacked and handled by the JS in the browser. Now, app rendered this way are called single page applications because they feel very fast since they are not making a round trip to the server to get the new page. So everything is happening essentially in one HTML file. So when the clients make the request to the server, well, the server sends back the JavaScript code from any of the framework used, for example, React, Vue, Angular, and which passes and render it into the HTML file. And this also hijacks any route changes, and okay, it's listened to, for example, you're going to the about page, well, it only updates the route right there inside of your browser address bar, but every other thing that is being shown is actually handled by the JavaScript framework. And we can see a lot of work is actually being done. Most of the work is done by the clients on the client side, and the server does little to no work, and the remaining of the work is actually done in the build time when you are running the build for production. Now, let's take a minute to talk about hydration. Usually in a single page application, when you're using client side rendering, when you get back the HTML and the JavaScript, well, there is a little amount of time before the page actually becomes interactive, and that is what is called hydration. Now, this hydration actually takes a bit of time. For the rendering of the HTML, that is very fast, but the hydration process can take a bit of time depending on how complex the application is. But don't be scared, in most cases, they are usually fast and instantaneous. But to dive deeper into what actually happens during hydration, well, when you get the HTML file, it's going to download all of the necessary JavaScript bundles or files associated with it. Then it begins to read through, pass and execute each of these JavaScripts, and it's going to attach all the necessary event listeners to all the right elements inside of the HTML file. And that is what just happens during hydration. Now, let's move on. SPA frameworks introduce components-based architecture similar to atomic design principle, where different parts of the UI can be made into reusable chunks or components. And that is where the idea of components actually got popularized. So as we can see right here, you can build very small components or atom and then combine them to form molecules and then organisms and then templates and then pages. So this single page that we can see right here can have different components which can actually be reusable by using things like props and so on. So this might just be one single component, but with different props and data passed through it, and same with this and same with the image we have right here. And then they can be combined together as needed and reused, which makes things very much awesome. Now, let's look at the pros and cons. Well, there are initial page load is very fast. There's great developer experience due to the component approach. There's great user experience and interactivity. There's reduced server workload, and it is very effective for dashboard or highly interactive application. Now, the cons is it can lead to slower rendering times on heavy apps due to the workload on the client. Remember that the client is doing most of the work here. So if you have a very low-end PC, well, it can be a bit apparent. There were years back when I was using a very low budget PC and not so good internet. When I would visit Facebook, for example, I would notice that there will be a time that my screen would just be blank for a while before I start seeing anything showing up. So that's one of the downsides of client-side rendering, and it is bad for SEO and social sharing as it makes crawling difficult. It has a lot of JavaScript dependency, and also the iteration process can sometimes be a downside. It can consume significant amounts of memory in the browser. Well, when it comes to languages and frameworks, well, since we mainly make use of front-end JavaScript frameworks, automatically we make use of languages like JavaScript and TypeScript. And when it comes to the frameworks, we have lots of frameworks such as Angular, React, Vue, Svelte, Solid, Quick, and so on. Now, some notable websites are Gmail and Facebook. Now, to reduce the amount of work that is being done on the client and make up for some of the cons of client-side rendering, that is why we have server-side rendering. Well, what happens in server-side rendering? Every initial page load is rendered on the server and sent to the client. Afterwards, JavaScript takes over in the browser to handle things like interactivity, page transition, just like in single-page application. So, essentially, server-side rendering equals to multi-page app plus single-page apps interactivity. So as we can see here, every page request is sent to the server. The server sends and processes the HTML to the client, at which point it is iterated and taken over by the JavaScript framework for things like the next page request and so on. In this case, a lot of work is being done on the server, and the client mainly takes care of things like the iteration. Now, let's look at the pros and cons where there is improved SEO. When it comes to client-side rendering, given the fact that we're getting just an empty HTML file and the JavaScript framework has to populate everything. But in this case, we're getting a fully populated HTML file, which is very great for SEO. There is faster initial page load, there's better performance on low-power devices, there's improved user experience, and it is very effective for content-heavy sites like a blog and so on. Now, let's look at the cons where there is higher server load and there can be slower subsequent page loads. There's complexity in development, limited offline support, and there is increased server complexity. Now, when it comes to frameworks that we can use, typical frameworks like Vue, Angular, React, and so on wouldn't work because they mainly focus on client-side rendering, and trying to make them work with server-side rendering well would take a little bit of work. And this is where we have meta frameworks such as Next.js for React, Next.js for Vue, and SvelteKit for Svelte. Now, let's move on to static site generation. So, this is a slight variation of server-side rendering, but it makes the server do everything at build time. So, all the pages, let's say you have a blog, and instead of when you click on a route as in SSR, the server puts together the HTML page and sends to you, where everything are rendered before ends. So all the dynamic pages are pre-rendered as they are compiled to static HTML. And afterwards, it pretty much works like SSR as JavaScript takes over things like routing, and essentially static site generation or SSG equals to SSR plus build time. So a lot of work is being done in the build time, and this is important to note, especially when you're having tons and tons of pages you're going to need to generate. Now let's look at the pros and cons. Well, SSG generates the static HTML files using the build process, so it results in very fast page loads. There's improved performance, improved SEO benefits, the hosting is simplified, and it's very effective for content-heavy sites. Now, static site generation is not great for apps where content changes frequently or where there are lots of updates. There is the build time overhead we need to consider. You have to redeploy whenever the data changes. Well, there is cache invalidation challenges, and then there is limited backend functionality. We can also use these meta frameworks we talked about. Well, Architechture is actually making use of static site generation. You can probably check that out. As you can see, one of the main pain points of static site generation is the fact that when your contents are updated, there really isn't a way to automatically update all of the pages we have. Well, that is where incremental static regeneration comes in. It was created by Next.js, and it makes rebuilding a page possible if the content is stale or based on specific rules. cache can be invalidated based on rules and updated. This makes it easier to handle dynamic data without the need for server-side rendering. So essentially, incremental static regeneration or ISR equals to static site generation plus revalidation. So the pros include all of the benefits of static site generation, plus it allows you to update specific pages with new data without fully rebuilding the site. For example, you might say that revalidation should be done every 10 seconds after a user visits the page. Now, it improves page load times by serving pre-rendered pages while allowing for dynamic content updates. It reduces build time and provides better user experience. Now, when it comes to the cons, well, things like caching strategies, data fetching methods, and fallback mechanisms can make it a bit more complex, can be resource intensive depending on the frequency of the content updates and the size of the app, and the revalidation is not instant. Concerning the frameworks we can use, well, we also use frameworks like Next.js and Nux.js. Now, earlier when I said Architecture uses static site regeneration, well, that's not completely true because it uses both static site regeneration and incremental static regeneration. Now, all of these rendering methods we've checked and we've looked at, they are all great, but they are sometimes due to their pros or their cons, or based on a specific use case, it might not really work that way. Well, that is where we actually have other rendering patterns which can be combined with some of the ones we've actually looked at. And the first one is partial hydration. Well, this is basically rendering the component at the top of the page first before the user scroll down, using techniques like code splitting and so on. So when it comes to full hydration, well, we basically have to hydrate everything at once, every part of the page, even if the users are not currently on that particular part or even might not scroll there. So to save time and memory, and that is where we actually have partial hydration come in. So let's say, for example, not every part of your web app is dynamic. Okay, we have the header here, which is static, the sidebar, which is static, and the footer. We can just run the hydration process for carousel, which requires some JavaScript interactivity. And this is going to make it much better and faster compared to the normal hydration process. Well, as far as I know, all major frameworks support partial hydration and features like code splitting and so on. Now, let's look at the next one, which is island architecture. Well, this usually starts with the HTML content and hydrate where needed, which gives a kind of island of interactivity. And this was mainly brought up and introduced by the Astro framework, and which is very cool. When it comes to Astro, you can use any framework to create any components. For example, you might have your header written in React, your footer written in Svelte, and so on. And when you create each of these components, you can tell Astro that, okay, yes, I want hydration here and hydration here. So you can selectively and strategically make them hydrate where and when needed. And a recent addition to the list is what we know as streaming SSR, which was recently brought in by, I think, Next.js 14 or so, and it allows for rendering SSR content in multiple chunks to make the UI interactive, faster, and feel more performance to the user. So here's a typical server-side rendering. There is no content in the browser while the content is being rendered on the server. So you basically have to wait for the server to put everything together and send it to the browser. And then the server rendered page is sent to the client once all the components are ready. But when it comes to streaming SSR, where there is a partial content with loading states and the content are streamed in. So think about it like, instead of making one single request to fetch everything and wait while that is done, well, I actually see this more like when you're making multiple fetch requests in JavaScript. Instead of making it sequentially, you can just use something like promise.all or promise.all settled and make all of the requests in parallel and reduce your wait time. So this is a similar concept that I think or can liken streaming SSR to. And the next one, or the last one I want to talk about for now, because you never know, tomorrow another rendering pattern might actually come out, and that is resumability. This is a new approach by the Quick framework to get rid of hydration and make all the dynamic data and event listeners serialized into HTML. So instead of we having this process where JavaScript is downloaded, passed, executed, and the event listener will be bound to each of the HTML elements, well, Quick solves that problem by serializing all of the event listener and data inside of the HTML and making the page automatically interactive while shipping very minimal JavaScript and a very minimal. So yeah, guys, we've come to the end of this video. What do you think? Which of the rendering method or paradigm do you think is the best? And let me know what your thoughts are. Let me know in the comment section below. Also, don't forget to like, share, and subscribe, and I'm going to see you in the next one.